Uh, Giri, I have give you the access. Okay.
Hello, am I audible?
Yeah, I have given you the access.
Yes.
Okay.
Just wait for a minute, okay? I'll just share my screen. Yeah, am I audible? Hello, am I audible? Am I audible? Just wait for a couple of minutes, okay? Can we start? Hello, can we start?
Yes, sir.
Yeah, great. First, is there any doubt in the activity questions?
No, sir.
Yeah. For others, is there any doubt in any of the activity questions?
No, sir.
All right, fine. Then I think I have a couple of questions. Maybe we can solve that. Okay. So the first thing is, yeah, this is the first question. See, there are two questions. Yeah. Now the first question is the following pseudocode is executed using a variant of scores dataset. Whoa, whoa. By variant, what I mean is the fields, the every card has the same fields, okay, but then the data is different. The number of cards might be different. Okay, it's a different variant. That's what it means. Okay, so this pseudocode is executed in a different variant of the scores dataset which we already have. Now at the end of the pseudocode, there are some questions. What does count store at the end? Okay, that's the first question. If there are 1,000 cards in pile 1, then how many comparisons will be done? Okay. What then for question C? Now this is binning. Okay. We are going to bin them in 4 categories A, B, C, D. After that, what is the total number of comparisons after binning? Okay. And question 4 is what is the reduction factor after binning? Okay. Can you all do this?
Yes, sir.
Yeah. So what you have to do is first read the pseudocode and answer the first question. See, the first question you have to answer in terms of a sentence. It counts the number of something like that. Okay. Count me, it's going to count the number of something only. Just return variable count. It can be A, B, C, D or anything. But then you have to say what the variable holds at the end of the pseudocode first. What does count variable hold at the end of the pseudocode? That's the first question.
Sir, first card stores the value of how many students have got the same number of marks.
How many students have got the same number of marks?
Yes, sir.
You're about what are you talking?
Sir, first question. A.
So you're saying that the count variable stores the number of students with the same marks, right?
No, sir. A pair of students.
Okay, number of pair of students with same marks, right?
Yes, sir.
Okay. Uh yeah. Others, one person has told that it is the number of pairs of students who have got the same total, right? What about others? What about others? Do you all agree with this? All right, I'll explain then. Yeah, actually, the the count variable stores the number of pairs of students who have got the same total. So what we are doing is we are picking a card X from pile 1 and we are moving that card to pile 2. And we are picking another card from pile 1. This is card Y. We are comparing card Y and card X here. After the comparison, we move Y to pile 3. And for all the remaining cards in pile 1, this will happen. After this while loop gets over, we'll move all the cards from pile 3 to pile 1 so that the next set of comparisons can be done. Now, in between, what are we comparing between X and Y? We are checking if the total marks scored by X and total marks scored by Y, we are subtracting these two. Yeah. And if that is equal to 0, we increase the count. So when will these two be 0? Sorry. When will this subtraction result to 0?
So when they both are same.
Yeah, when they both are same, of course the subtraction will become 0. So that's what this means. So count is going to count the number of pairs of cards with same total marks. Okay? Yeah. Now second question. If there are 1000 cards in pile 1, then how many comparisons will be done?
Sir,
That is, here is the pile 1 and these are the comparisons. Now how many comparisons will be done?
1
so
lakh
999 into 1000 by 2.
1,99,800.
Sorry, 1 second. Yeah.
Sir, 4,99,500.
4 lakh.
99,500.
Yeah, 1 second. Okay, 4,99,500. Anything else? Somebody told 1,98,200. Somebody told. Is it? Anything else other than this? Okay. Yeah, the answer is 1000 into 999 by 2. Okay.
Sir, sorry, it was 1,99,800, sir.
1,99,800.
800.
Yeah. The first one, how did you get? The person who answered this, how did you get 4,99,800 for 1000 cards? How did you get 4,99,800?
Sir, 999 into 500.
999 into 500 you read. Okay. And what about this one? The other person who answered, how did you get 199,800?
1,000 into 1,000 minus 1 divided by 2.
Oh, 1000 minus 1 divided by
Divided by
2, which
2.
is 999 by 2.
Yes.
Yeah, then I think you should be getting 499,500. See. Oh, yeah. See, it is 1000 into 999 by 2. 499,500. Where are you
I
getting
think
this?
something went wrong, sir. I'll check it.
Yeah, it is 4,99,500. Oh, like what is the reason? It is n into n minus 1 by 2, right? Yes?
Yes, sir.
Yeah. How did n into n minus 1 by 2 come up?
Sir, we
Okay,
have
I'll just. Yeah.
Sir, if we drew all of them as points, sir, in a circle, then we have to join all the points. So then we'll have 1000 plus 999 plus 998, all those many times.
Yeah. 1000.
So,
No, not 1000. From 999, right?
yes, sir.
Yeah. 999 plus
Plus
998
998
all the way up
to
to.
1.
Yeah, to 1. Right?
If we generalize this,
Zero,
we get
to
this.
0 actually. Now,
Yes,
what is this one? Like what he is saying is, let's say there are 5 points, okay? We want to select pairs. Now for this point, you have to join with 4 other points. So 1, 2, 3, 4. Now for this point, you have to join with 3 other points because this point is already over. right? So 1, 2, 3. Already we had 4, 4 plus 3, 7. Now for this point, it is already this is okay. This is also okay. So only 2 more points, right? So 7, 8, 9. And for this point, all these 3 points are connected. Only this point is yet to be connected, right? So 1. So totally it is 10, right? Like what we are doing is, do you all remember arithmetic progression in which you learned in class 10th? In 11th also, I think you would have learned. Yeah.
Yes, sir.
What is arithmetic progress? What is the sum of an AP?
Sir,
N
n
by
by 2
2
into 2a plus n minus
n
1
by
into d.
into D, right? Now here, what is n? N is 5. 5 by 2. What is A?
1.
Sorry, no. I'm talking about the sequence. There are 5 notes, right? Sorry, 5 cards. A, let's say name this A, B, C, D, and E. Now for A, we had to connect it to 5. Sorry, we had to connect it to 4 other cards. For B, it was 3. For C, it was 2. And for D, it was 1. And for E, it was 0, right? So N is 5. This is the sequence. 4, 3, 2, 1, 0. This is the sequence, right? We need the sum of this sequence. Yes or no?
Yes, sir.
Yeah. Now N is 5. A is 4. What is D?
1.
1. Is the sequence increasing?
-1, sir.
Yeah, -1. So when you plug these things into the formula, what will you get? N is 5. 5 by 2. 2a is 2 times 4, which is 8. Plus what is n? 5. 5 minus 1, 4. 4 into -1 is minus 4. So 8 minus 4 is 4. Outside you have 5 by 2. So 5 by 2 into 4 will become 10. Right? Now similarly for 1000. First of all, is this one clear? Yeah? Is this clear? Hello?
Yes, sir.
Yeah. Now for similarly for 1000, for the first card, you have to connect it to 999 more cards, right? And for the second card, you have to connect it to 998. Third card, it is 997. Now for the 1000th card, to how much should you connect? To how many other cards should you connect?
0, sir.
0, right? Because for the first 999, everything is connected to 1000. So you need not connect this to anything else, right? So overall, the sequence is from 999, 998 all the way up to 0. So n is 1000 cards. A is 999. D is -1. Okay. So 1000 by 2 into 2 times A. 999 into 2. 2 times 999 minus 1000 minus 1 is 999 into -1. Sorry, 2A plus n minus 1 into D. Right. So now this becomes, now if you take this minus here, it becomes 2 times 999 minus 999. Right. So 2 times 999 minus 999, what does it become? These two together will become 999, right? See,
Yes, sir.
2x minus x is x. So similarly, 2 into 999 minus 999 is going to become 999. Right? So this 1000 into 999 by 2. So overall it is 4 lakh 99,500. That's what the calculator showed, right? Yeah. Now I'll just give another way to look at this, okay? See, yeah. See, you have n cards, right? Card 1, card 2, card 3, all the way up to card n cards. Similarly, at card 1, card 2, card 3, all the way up to n cards, right? Yes. I'm just talking in terms of comparison. So this point is going to compare 1, 1. This point is going to compare 1, 2. This point is going to compare card 1 and card 3. This point is going to compare card 1 and card n. Okay. Now this is going to compare card 2 and card 3. This is going to compare card n and card n. Like this, we are going to compare everything, right? Now from these things, is there any point in comparing the same cards?
No, sir.
Yeah. Now first, overall, how many comparisons are there with this? How many comparisons are there? N this one and n here. Overall n square comparisons, right?
Yes, sir.
In this box, overall n square comparisons. From this, you don't need these diagonals, right? These comparisons are not necessary, right? What is the point of comparing 1 and 1, 2 and 2, 3 and 3, right? Yes.
Yes, sir.
So from n square, you subtract n. Okay. Now, if you compare 3 and 1, then there's no point in comparing 1 and 3. If you compare n and 1, then no need to compare 1 and n. If you compare 2 and 1, then no need to compare 1 and 2. So these are the remaining, okay? The blue shaded part is the remaining. Right? Now these blue shaded parts, both the partitions are equal, right?
Yes, sir.
This one and this one are equal, right? And the sum of these two is only n square minus n, right?
Yes, sir.
Now half of these are unnecessary. If you compare these things, then comparing these things are unnecessary. Because if you compare card A and card B, then if you are going to compare again card B and card A, the second one is unnecessary, right? So half of these are unnecessary. So you take out half. Half means you divide it by 2 and you will get the other half. Right? So from this one, what will you get? N square minus n, you take n common. N into n minus 1 by 2. Okay? Right?
Yes, sir.
Yeah. I just wanted to show that. So it is 499,500. Now for the third question. Now for the third question, we are splitting the cards into bins, okay? One second. Now we are splitting the cards into bins. Okay. All right. There's category. This is bin A, bin B, bin C, and bin D. That is, we are splitting them into 4 categories. The 1,000 cards were there, right? We are splitting them into 4 categories. Now, how many comparisons will be done? How many comparisons will be done for each category? That is, overall we had 1,000 cards, okay? Of those 1,000, 200 cards are above 260 marks. The total marks of 260. We move them to bin A or category A. 350 cards were lesser than or equal to 260 but greater than 200. So we move them to bin B. 280 cards were lesser than or equal to 200 and greater than 160, we move them to category C. And 170 cards were lesser than 160, we move them to bin D. Now these ranges don't have. What is the intersection of all these 4 ranges? What is the intersection of all these 4 ranges? Hello. By intersection, I mean, is there anything common between these ranges?
No, sir.
No. Right. So the intersection is a null set. Because this is greater than 260, this is from 260 to 200, this is from 200 to 160, and this is less than 160. Once again, this should be lesser than or equal to 160. Yeah. Okay. So overall, if you add these things, you will get 1000. Okay. Now, how many comparisons will be done? Find out.
Sir, 1,34,400.
1,34,000 overall, the total.
Yes, sir. Overall.
Overall, everything put together is 1,34,400. Any other answer? We'll find out. Any other answer? Is there any other answer? See, can you all understand the question? Of all the cards, of the 1000 cards, we have split them into different ranges, and according to the range, we have put them into different categories. Now, one thing to notice, the bins are not equally distributed, right? So for every bin, the number of comparisons is going to vary, right? Now, for example, if there are 200 cards, so within category A only we are going to compare, right? Is
Yes.
there any point in comparing a card from category A and category B? There's no point, right? We take some card from category A and we compare it with category C. There's no point. Because what do we want? We want to count the number of pairs of students who have got the same total. If they are in different categories, definitely there's no possibility of them having the same total, right? So there's no point in comparing those two cards from different categories. So within this category, we will however compare. So for 200 cards, how many comparisons will be there? It is 200 into 199 by 2. Yes or no?
Yes, sir.
Yeah. 200 into 199 by 2. And for 350 cards, it is 350 into 349 by 2. And for 280 cards, it is 280 into 279 by 2. And for 170 cards, it is 170 into 169 divided by 2. Now, what is the sum of all these things? Sum of all these 4, it is 1,34,400. Right? Understood?
Yes, sir.
Yeah. Others? Can you all respond?
Yes, sir.
Yeah.
Yes, sir.
Right. So the overall the total number of comparisons is 1,34,400. Now coming to the fourth question. By how many factors have the comparisons reduced after binning? By how many factors have the comparisons reduced?
Sir, 3,65,100.
By 3,65,100 factors? No, understand. I'm not asking the difference, okay? I'm asking by how many factors have the comparisons reduced after binning. After you bin the cards, by how many factors have the comparisons reduced? Yeah, I'm not asking the difference. I'm asking by how many factors. Reduction factor, right?
So 3.7.
3.7. Okay. Any other answer for anybody? Is there any other answer? One person has told that the reduction factor is 3.7. Anything else? Okay, fine. What is the formula for reduction factor? What is the formula for reduction factor? What is the formula for reduction factor?
N minus 1 divided by N by K minus 1.
Okay. Will you use that here? Sahitya, will you use that here? For this question, will you use it?
Not for this, I think.
Yeah. When will you use that then? What is that formula for then? What will you use that for then? For what will you use this reduction factor? See, the difference is this n minus 1 by n by k minus 1. You should use this formula only when the bins are of equal size. If the bins are of not equal size, then you shouldn't use that formula, right? Yes. Now here the bins are of unequal size, so you don't use this formula. What will you use then? What will you use then? You have to find the, what is the reduction factor now? It is the number of comparisons before binning divided by number of comparisons after binning, right?
Yes.
So 4,99,500 divided by 1,34,400. So it is 3.71, which is approximately 3.7. Right? So the formula is basically the number of comparisons before binning and the number divided by the number of comparisons after binning. This n minus 1 by n by n minus n minus 1 by n by k minus 1 should be used only when the bins are of equal size. Okay. Is it fine? Can we go to the next question?
Yes, sir.
Yeah. Now for the next question, I think this is also an easy question. The following pseudocode is run using BERT's dataset. What does P store at the end? What does the variable P store at the end of the dataset?
So pairs of words which have the same part of speech and same letter count.
Okay. Anything else?
Sir,
Same
sorry, sir,
part.
not same part of speech.
Then
Having the same letter count, but don't have the same part of speech.
okay. Others?
So having the same letter count and not the same part of speech.
Yeah. Yeah, this is also a simple question, right? You pick the card, that is card X, you pick it from table 1, you move it to table 3. And you pick card Y from table 1, move it to, oh, yeah, move it to table 2. Now you compare X and Y here, right? And after that, after this gets over, this while loop gets over, for all the cards in table 1 other than X, you come outside the while loop, right? After you come outside the while loop, you move all the cards from table 2 to table 1 to do this for the remaining cards. Now, in between, what is happening in between? If the letter count of X and Y are same, and if their part of speeches are different, this equality symbol double equal to is for equality, and not equal to should be is used by this symbol, right? So same letter count and different part of speech. If that is the case, we increment P. So it is going to be the number of pairs of cards, sorry, number of pairs of words with same letter count and different part of speech, right?
Yes, sir.
Okay. Yeah. Now, this is another question. Maybe you people can write this, or it's more like fill in the blank. Now, what I want is, uh, there are. This is basically for the C will, the variable C will have the number of sorry, the variable C will have the number of words which start with a consonant and end with a vowel. Okay. So what you have to do is you have to fill this one within this. How can we go about this? We want to count the number of words which start with a consonant and end with a vowel. Or maybe we can do this where all the uh,
Sir, for I is equal to 1,
okay.
letter
uh,
is X letter is not equal to vowel, and for
X, X letter is not equal to vowel.
yes letter, yes sir,
That is, I'll just type the condition alone first. X dot X dot letter, X ith letter, right?
yes sir,
Ith letter not equal to vowel. This is what you're saying, right?
sir. At I is equal to 1.
Yeah, that is fine. We'll come to that. But is this a valid line? Is this line valid? Ith letter is fine. But what is vowel? Like it is not a data type, right? Is
Sir,
it
we
a
have to write
is it
A
a
E I
variable?
O U
Is
separate.
it a variable or is it something? We can in the
Sir,
as a pseudocode you can simply write ith letter is not a vowel. We can simply write, right? Yeah.
yes sir.
Hmm. So one thing is the first letter should be a vowel. By first letter, how can we identify the first letter?
Sir, I is equal to 1.
Okay, if phi is equal, others also can talk. Others also can unmute and speak. No. Yeah. See. Yeah. If I is equal to 1, then it is going to be for the first letter. Okay. If if ith letter is a vowel, then what will you do?
No, sir. If ith letter is not a vowel.
Okay. If ith letter is not a vowel, then what will you do?
So, and then again we have to go to another if statement.
Inside this.
Yes, sir.
Okay.
If I is equal to n, and if ith letter is a vowel. So
If
I is equal to n.
if I is equal to n, what is n?
N is the total number of letters.
That is the letter count, right?
Yes, sir.
Okay. If I is equal to letter count, then
If ith letter is a vowel,
if ith letter is a vowel, then
some
This is a
variable y is equal to y plus 1.
C, no.
So yes,
Here
sir.
C for
C.
count.
Yes, sir. C is equal to c plus 1.
C is equal to C plus 1. This is what you are saying, right?
Yes, sir.
Okay. Anything else with this? Anything else? Do you want to add anything else here?
Sir, move card x to pile 2.
Okay, that is fine. Move card X to pile 2. Okay. Others, do you all agree with this? Do you all agree with this code? Is there any change which we can do to this code? See, in the second class, I told you that I told you something about the while condition, right? What was it? What should be the property? What should be a property which should be satisfied by the while condition? What property should be satisfied by the while condition? Atendrun? The while loop must terminate, right?
Yes, sir.
Yeah. Now, for example, if the letter count is 5 and now I is 1 now, will this ever terminate? No, right? So you have to increment I, right?
So I is equal to I plus 1.
Yeah, that should be there, right? Otherwise, this will not terminate. Yes?
Yes, sir.
Yes, sir.
Yeah. And one more thing. Now, in terms of logic, the very reason why you are there in this line is because all these conditions are correct, right? The very reason why this line is getting executed is because these conditions were correct.
Yes, sir.
Now, can you see a contradiction? If I is equal to 1 and if I is also equal to letter count, is it going to be possible?
No, sir.
No, right?
Sir, we put I is equal to I plus 1 before and
Yeah.
then introduce.
Where should you put? Here.
Yes, sir.
Then it will be the second letter, right? It will be the second letter, right?
Yes, sir, but it does not satisfy the if condition. Oh. Then we have to
No.
write else.
Okay, like what is the flow? What is the flow? What is the basic idea?
I is equal
You
to
can
I plus 1
identify. See,
until we reach the last letter.
you can identify the first letter with I is equal to 1. With this condition, you can identify the first letter. With what condition can you identify the last letter?
I is equal to X letter counts.
Yeah, if I is equal to the x, if I is equal to x dot letter count, then it means that it is equal to the last letter, right?
Yes, sir.
Yeah. But then without I is equal to 1 or I is equal to let x dot letter count, can you all think about a different way to do this? Hmm? Or maybe I'll give an idea. You can maybe take this out. We need that condition, like we need to modify that. Let's say A is equal to true. Okay. Now with this, you have to fill this part and this part. Now one thing will be I is equal to I plus 1. You have to increment the letter count, right?
Yes,
Or
sir.
do you need to even iterate, or you can it? I'm just saying the iterative way. You can do it without iteration also. Now let's say we have to iterate through every letter to find whether we have to increment C or not. What can you do now? Now you have to go through every letter, right?
Yes, sir.
I'm just saying that you go through every letter and after that say, count. Okay. First go through every letter and then count. In that case, you have to go through every letter.
So while I is lesser than or equal to letter count
X
or
dot
letter
letter,
count.
letter count. Yeah. Now with this variable a, what can you do? How can you use variable a?
Sir, with A we can see if first letter is
Or
consonant.
maybe 1 second, you can have another variable b is equal to false. It will be easy. Yeah. Now make use of these two and say. Okay. Maybe I'll give the idea and you can translate it into code. See, you're going to go through every letter, okay? Letter 1, 2, 3, 4, 5, maybe. Now, when you look at the first letter, what is the state of A? True, right? Here A is true. For the first letter, definitely A is true, right?
Yes, sir.
Yes, sir.
Now, after looking at the first letter, if you can make A as false, then for all the remaining letters, A is going to be false. So, if A is true, it means that we are looking at the first letter. If A is not true, then we are not looking at the first letter. We can make it that way, right?
Yes, sir.
Now, with that, what can you do? What can you write here? So, for the first letter, A should be true, right? So, one condition is if A is equal to if A, that is if A is
A
true,
is
right?
true,
And what is the other condition? If A is true, then what does it mean? It's the
B is
first letter.
false.
Okay. If A and not B, that is fine. See, this B should have the B will be true when the first letter is a consonant, okay? Right now it is false. So before looking at any letter, we assume that the first letter is not consonant. And when we look at the first letter, if that is a consonant, we'll make it true. Remember, to in conditional termination, first we assume found to be false, thinking that the card which we want will not be there in the data set. The moment we found the card, that found variable became true, right? Yes.
Yes, sir.
Similarly, first we'll assume that the first letter is not a consonant. Now, if the first letter is a consonant, we'll make B to be true. For that, what can we do? If A and ith letter is a consonant, we can make B as,
B is
we can
equal to
assign true to B, right?
yes, sir.
Now, if after this, now at this point, the star point, if B is true, we can say that the first letter is a vowel, right? Sorry, consonant. Yes,
Yes, sir.
Yes, sir.
can we? But we have not. But for the second letter also, now A is going to be true, right? Here, when I gets incremented, for next letter also A is going to be true. If that is also consonant, still B will be true. Maybe the first letter, for the first letter was a vowel, but the second letter is a consonant. Still this condition will become true and B will become true, right?
Yes, sir.
Yes or no? So how do we, it's an issue, right? How do we tackle that now?
Sir, A if A and B is, sorry,
Okay, if
no,
we,
sir.
we write it inside or outside. See, what I want
We
is,
write it after I is equal to I plus 1, sir, outside.
see, what I want is, exactly, exactly. After here, on top of that, we can write A is equal to false, right? That's what you're saying, right?
Yes, sir.
So what does it mean? Like what I want is, if the, for example, before that line, if the first letter was a vowel and the second letter was consonant, if we didn't make this change, then for second letter also A is going to be true. Now it is a consonant. Now both these conditions are okay. So we are going to make B to be true in this point, right? We don't want to do it now, but because the first letter is not a consonant, we don't want to make B to be true, right? So one of these two conditions should not get satisfied. Now, if this is a consonant, we cannot make it into a vowel. It will remain as consonant. So how to change this one? After the first letter, we'll make A to be false, right? Right?
Yes, sir.
Yeah. So if we make A to be false for all the other letters, when I is equal to 2, 3, 4, 5 and so on, A will be false here. A will not be true. But and during every iteration, A will get assigned to false. It will again and again get reassigned with false. That is a point to note. Okay. Now what I'll say is, now for the last letter, how do we for first letter we use variable A. Now without using variable A, without using any other variable, is there any way to find the last letter? Is there any way to look at the letter and see that the last letter is a vowel? What I'm saying is there any
Sir,
other way to?
A should be false and B should be false.
Okay. See, for example, if the first letter is a vowel, then B will be false. Now A becomes false after that. Now for all the remaining letters, A is false. B is also false. What I'm saying is there any unique way to say that the letter we are looking at is the last letter?
I is equal to letter count.
Okay, that is one way to do. That is fine. So what you're saying is, if I is equal to x dot
No, sir.
letter count.
After we end while, sir.
See, after we end while loop, I is equal to I plus 1, it gets incremented. That's why the condition becomes false. If it was equal to letter count, if I was equal to letter count, we would be going inside. What is the reason we are coming outside? Because I got incremented and it became greater than letter count. That's why we are coming out, no?
Yes, sir.
Yeah. See, I just want to mention this probably. See, when you look at the first letter, first I is 1 here. After you look at it, I becomes 2. For second letter, I is 2 here. After you look at it, it becomes 3. So similarly, for last letter, if it has 10 letters, before you look at it, I is 10. After you look at it, I becomes 11, more than the letter count. So when you come back here, 11 lesser than or equal to 10 is false. That's why you come outside. Right?
Yes.
So what? So we have to check it here, right? If I is equal to letter count, if ith letter is a vowel, now what will you do again?
A is equal to false, B is equal to false.
No, you need not. See, A is only for the first letter. After that, nothing to do with A. Is there any way to use B? See, if I write, if ith letter is a vowel and B, what does it mean? The last letter is a vowel, and if B is true, what does it mean? The first letter was consonant, right?
Yes, sir.
So for this, we can write C is equal to C plus 1, right?
Yes, sir.
So in this way, it will get okay, right?
Yes, sir.
Yeah. Understood, others? Did you all understand this one?
Yes, sir.
Yeah. But then there's another way to do this. What we can do is probably, instead of writing lesser than or equal to, we'll put it as lesser than letter count. So when we come out, the value of I will be equal to letter count, obviously, no? See, from lesser than or equal to, we change the condition to lesser than. So what does it mean? The moment we are coming out, sorry, at this point, I is equal to letter count, right? Yes. Can you get the point? What I'm trying to say?
Yes, sir.
If from lesser than or equal to, if we change it to lesser, then what will happen is, if there are 5 letters,
Sir, then we'll only have to evaluate 4. We don't have to evaluate the last letter.
yeah, we'll only do 4 iterations for the first 4 letters. Letter 1, letter 2, letter 3, letter 4, letter 5. Okay. Before looking at the first letter, I was 1. After it became 2. Here from 2 it became 3, 3, 4. Before looking at the fourth letter, it was 4. After looking at the fourth letter, it became 5. Now 5 lesser than 5 is false, right? So we
Yes, sir.
won't be looking at this letter within the while loop. So when we come out, the value of I is 5 now. Value of this variable is 5 now. So we can simply write, if ith letter is a vowel and B, C is equal to C plus 1. We can reduce one iteration with this. Okay. This is another way to do. Right. Yes. Can you get the point?
Yes,
Yeah.
sir.
Actually, technically this iteration itself is not needed, right? Technically, you can write I is equal to 1, J is equal to X dot letter count. If ith letter is a consonant and jth letter is a vowel, then C is equal to C plus 1. You can do this, right? We could have done this like this also, right?
Yes, sir.
Without iteration, we could have done this. But the reason why I wanted to show iteration is because I just want when you okay, right now you are in 12th. No. So once you do the full computational thinking as a part of foundation course, you will be learning something called as list. Okay, it is actually there in week 5. But now the school connect it gets over by week 4. No. In week 5, there's something called as lists. Okay. In lists, what you'll do is you'll be iterating. That's a different way to iterate. See, in week 3, you saw, no, there was something called as first topper, second topper, third topper. No, first topper variable will have the sequence number of the student with the highest mark. For example, 0 to 15. So this is the first topper, second topper, and third topper. Now for 3 toppers, we need 3 variables, right? Yes.
Yes, sir.
Yes.
Then if then at some the real world data is going to be too big, and sometimes maybe not 3, you want 35, 350, something like that. In that case, you cannot have 350 variables. You cannot sit and create 350 variables. V1, V2, V3, you cannot sit and type those many variables. So for this, you need a way to collect these things, right? Whether it is 3 variables, sorry, whether it's about 3 items or 3 data items or 300 data points or how many ever you want it to get collected, right? You want to collect them and put it together. 0 to 15, like this you want to collect it, no?
Yes, sir.
So when you collect them together, what you can do is you can go one by one. When you go one by one, you can iteratively go and see that this is the first element, second element, third element, you can see. So for those things, the different ways which I told you, no, different ways to iterate over the words, assuming that only for the first word, different ways to iterate over the letters. One thing is you assume that for the first letter A will be true. For all the remaining letters, A will be false. That is one way to get the first letter. How do you get the last letter? Instead of writing lesser than or equal to, you write only lesser than. So when you come out of the while loop, automatically I is the last letter. Or if you put it lesser than or equal to, you can write if I is equal to letter count, and if variable B is true, then what we wanted is there, no? See, we can increment C, no? So these are different ways to iterate and manipulate Boolean variables so that we can get what we want. So when you learn lists, maybe you will be doing much of these. And when you sit and code, maybe in Python course later on, it will be you would have to think about these things and code. There would be much better example. What I gave is a silly example, right? Just to find the first letter and last letter, I just asked you to iterate over every letter. For demonstrating, I gave you this example, but when you sit and code, you will be getting much better problems which you have to solve. Okay.
Yes, sir.
Yeah. So with this, is there any doubt? Is there any other doubt in week 4? Like in any practice question? If there's any doubt, we can solve that now. Is there any doubt? All right. Okay. So I'll just say one more thing and then we can probably wind up. Another reason why it was n into n minus 1 by 2 was because you remember combinations, permutations and combinations from class 11. What is the formula for NCR? What is NCR? It is n factorial by n minus r factorial into r factorial, right? This is the number of ways you choose something. Out of n items, how many how many ways are there to choose R items, right? This is NCR. No. Hope you people have learned this.
Yes,
Yes.
sir.
Yeah. Now here you want to choose 2 cards from n cards. So it is NC2. It is n factorial by n minus 2 factorial into 2 factorial. 2 factorial will become 2. What is n factorial? N into n minus 1 into n minus 2 factorial. Do you all agree?
Yes, sir.
Yes, sir.
Yeah. And divided by n minus 2 factorial into 2 factorial. Sorry, into 2. You cancel these two, so you will get n into n minus 1 by 2. So this is another way to see why this formula is correct. All right. Okay. Anything else? Any doubt from week 1 to week 4? Overall, is there any doubt?
Sir, I have
Yeah.
a question from practice assignment.
Which
Sir,
question?
question number 7, I guess, sir. There is one question about vowels occurring consecutively. I do not understand that part.
In week 4, right?
Yes, sir. Week 4.
Practice assignment, question 7. Okay. What does... Oh, sorry. This is question 10. Yeah. Now, what will count represent? In this question, you have a doubt, right? Like you don't
Yes, sir.
understand, or you want me to explain this question, right?
Yes, sir. I did not understand how we got the consecutively part.
Yeah. Okay. See, the thing is, I think till this part, maybe you would understand. Till while letter count is lesser than or I is lesser than or equal to letter count, till that line, maybe I think it should be okay. Because that's just the basic thing, right? That is what I'm saying is, till this part, I think it should be fine. You're picking the card, you move the card, and for every, this is for every card, okay? For every card, you initialize these variables. Okay. After this is for iterating over every letter. For every letter, you increment I. So this overall while loop is like this. Now within this, we have to look, right? So I'll explain this part. Now, first A was false, right? For every word, A is false at the beginning, right? At the beginning, A is false for every word. Now,
Yes,
when is
sir.
A becoming true? When is A becoming true? If the word is a vowel, right? If the
Yes,
word
sir.
is a vowel, A becomes true. Otherwise, A becomes false. Now, when is B becoming true? If A is true, right? Now, for let's say if the first letter is a vowel, let's say the first letter is A. Now, for the first letter, is A true? No,
Yes,
right?
sir.
No, at this point, at this line, you go like one by one, right? You go through 7th line, then 8th line, then 9th line, then 10th line. Only at the 10th line, A will become true. When you read it this way, only in this line, A becomes true. In this line, now A is false, right?
Yes, sir.
So when you look at the vowel when you look at a vowel for the first time, A is false. So you cannot make B to be true. Now A becomes true. Okay. Now if the next letter is not a vowel, then this if condition is false. So you have to definitely execute the else block. Right? For the
Yes,
else
sir.
block, A becomes false. Here A is true for the first letter. Now for the second letter, A became false. Now if the third letter is again a vowel, now A is not true, right? Because the previous letter was false. Because of that, now A is not true. For the first letter, A was not true because that's the way it was initialized. But for the third letter, even though it's a vowel, A is not true because the previous letter was not a vowel. Right?
Yes, sir.
Yeah. So this if condition won't get executed. But we'll make A to be true again. Now if the fourth letter is also a vowel, Now A is true, right? Because the previous
Yes,
letter
sir.
was a vowel. Because of that, A is true now. If that is the case, we make B to be true. From false, B became true. Okay. Now, one thing to notice is if B becomes true, then B will never become false again for the same word, right? For a given word, if B became true once, nowhere does B become false after that. Yes or no?
Yes, sir.
So what does it mean? If B is true here, what does it mean? There's at least
There are at least two words, two
there's
letters.
at least two letters which are consecutive with each other and are also vowels, right?
Yes, sir.
Now, if the next letter is also a vowel, again A is true. So again B will become true. But B is reassigned to true. But B is never assigned to false after that. You can reassign B to true, but you cannot assign B to false. That is once B became true, right? So
Yes, sir.
because now there are two consecutive pairs of vowels, that's why it is not exactly one consecutive pairs of vowels, but then it is at least one, right? And we increment the count if there are at least one consecutive pairs of vowels, right? So which option is true in that case? With at least one
First
pair
one, sir.
of vowels occurring consecutively. Let us check them. Yeah, understood.
Yes, sir.
So try to practice as many questions for this letter, these kind of questions, okay? Because this will make you to understand how these variables are used, the way these variables can be manipulated to get what we want. So look into this. How just think about how you can use these variables and boolean values to get what you want. You assume something not to be true, then you make it true when you find something, or you assume something to be false. The moment you find something, you make it true, or you assume something to be true, and the moment you see that it is not something like that, you make it to be false. That is, these are two ways to, you know, use the variables, boolean variables. So think about more examples. Okay, anything else? Any other doubt?
No, sir.
Yeah. And for consecutive part, we have two variables for two letters. Okay, that is also there. So you need to have adequate number of variables also. All right. Okay, anything else, or we can leave then? If there's nothing, then we can leave.
Thank you, sir.
Yeah. Thank you
Thank
so
you,
much.
sir.
Thank you, sir.
All the
Thank
best.
you, sir.
Yeah, yeah. Thank you so much. Okay, all the best. Okay, bye. Overall, from week 1 to 4, there's no doubt, right? Overall, there's no doubt, right?
No, sir.
Okay, fine. Try to practice more questions. Maybe the questions won't be as easy as these sometimes. So if the concepts are clear, then maybe I think you should be able to answer. And if at some point you are stuck, maybe by yourself you prepare 3 or 4 cards. You can simply draw on the rough sheet, prepare 3 or 4 cards, and maybe you can manipulate with those cards, do the procedure which is there in the pseudocode, and manipulate with these 4 cards, 4 5 cards, and you'll get an idea of what the code what is going on. Okay,
Okay, sir.
yeah, think about examples and so on. fine. All the best and bye. Okay.
Thank
Yeah.
you, sir. Bye.
Yeah. Thank you so much. Bye.
Thank you, sir.
Yeah.